Welcome! In this video I'll be teaching how to solve an example SAT math problem about radicals. This is one of those SAT math problems towards the end of the no calculator portion of the test. These types of questions can be tricky if you aren't prepared, but if you practice with Daniel the Math Tutor, you'll do fine. I'll be discussing radicals at the SAT math level, so if you're preparing for an SAT, this is the info you need to know. Here is an example problem from a practice SAT. If a equals 5 root 2 and 2a equals the root of 2x, what is the value of x? So, in order to solve this, we need to understand 1, the math rules for radicals, and 2, how numbers can be factoring. So first of all, let's remember this rule about radicals. This is called the product property, although you don't need to remember the name of the property for the SAT. Just remember how this works mathematically. The square root of a times the square root of b is equal to the square root of a times b under the same radical. And this always holds true no matter what the index of the radical is, whether it's a square root or a cube root or to a fourth root. So, for example, square root of 2 times root 3 is equal to the root of 2 times 3, so root 6. Okay. Another example, root 5 times root 7 is equal to the root of 5 times 7, so root 35. This property of radicals is important to remember for SAT math problems. Next, we need to think about factoring numbers. So factoring a number is the process of finding the factors of that number. Factors of a number are numbers which multiply to produce that number. So for example, factors of 8 are 4 and 2, because 4 times 2 equals 8. Factor. Typically when factoring, the goal is to break the number down to the product. The goal is to break the number down into the product of as many small integers as you can. So 4 can probably be factored further. So let's take a look at that. First, let's remember the definition of a prime number. Prime number means a whole number that has exactly 2 positive integer factors, which are itself and 1. So 2 is prime, but 4 is not prime. We call that composite. So of these factors of 8, we have 4, which is a composite factor, and 2, which is a prime factor. So let's see. Notice that any even number greater than 2, such as 4, can be divided by 2 into another whole integer. 2 is always a factor of any even whole number, so when starting to factor an even number, a good place to start is always just divide by 2. Like this. 8, 4, and 4 can be factored further. So let's try another example. The prime factors of 16 are 2 and 2 and 2 and 2. But let's go one step at a time. The factors of 16 are 8 and 2, because 8 times 2 equals 16. 2 is a prime factor, but 8 is composite, and we can factor further. So factors of 8 are 4 and 2. Notice, let's see. Yeah, so we factored a little further, but we still have a composite factor, 4, and we have 2 of these prime factors, 2. So let's factor further. The next step would be breaking that 4 down into 2 times 2, because 2 times 2 is 4. The prime factors of 16 are 2 and 2 and 2 and 2. The process shown here is called prime factorization, because the number 16 was factored until no composite factors were left. See how we went step by step until we had all prime factors. So let's see. Noticing this example, the factors of 16 are all the number 2. Sometimes the SAT may ask you for the number of prime factors. In this case, there are 4 prime factors. However, notice that they are all the same number, the number 2. Sometimes the SAT may ask you for the number of distinct prime factors. So just remember that distinct means unique. It just means different, unique. So how many distinct or unique prime factors are there of 16? Well, only one. The number 2 is the only prime factor. So that's important to remember. Prime factors. 2, 2, 2, and 2. There are 4 prime factors, but there's only one distinct prime factor. So, back to the original problem. If a is 5 root 2 and 2a is root 2x, what is the value of x? In order to solve this, first take notice that we've been given 2 equations with 2 variables. Anytime you have 2 equations with 2 variables, you can solve for the values of both variables using substitution. So a equals 5 times root 2 is given as the first equation in the problem. So write that. To solve for x, look at that equation that contains x. So which equation in the problem contains x? The second one. 2a equals the root of 2x. So this one contains x. So what we need to do is substitute the value of a, 5 root 2, into the second equation. So let's do that. The left-hand side of the second equation is 2a. So let's take 2a and substitute in the 5 root 2. So now we have 2 times 5 root 2. Following order of operations, this produces root 2 times the product of 2 and 5, which is 10. So basically 2a equals 10 times root 2. Now we're ready to substitute this value, 10 root 2, into the left-hand side of the second given equation. After substitution, the new resultant equation is 10 root 2 equals root 2x. So now we have one equation with one variable x. We can manipulate the equation to solve for the variable x. Since the x is currently inside a radical, it's under here with the 2 multiplied times 2 on the right hand side of the equation. Let's square both sides of the equation because this will free the x from the radical. So the first step would be to start isolating for x. We will square both sides of the equation. So squaring 10 root 2 means multiplying 10 root 2 times itself. Since these numbers are all multiplied together, they can be reordered or multiplied in any order. So we should remember all of this information here. How to square this left-hand side of the equation, 10 root 2, that is equal to 10 root 2 times itself, 10 root 2 again. And 10 root 2 is 10 times the square root of 2. So this is really just 4 numbers multiplied times each other. So since these numbers are all multiplied together, they can be reordered or multiplied in any order. This is called the commutative property of multiplication, but you don't need to remember the name of the property for the SAT. Let's multiply the two 10s together and multiply the two root 2's together. 10 times 10 equals 100, and root 2 times root 2 equals 2. So this is what's going on here to give us 100 times 2. So therefore this expression evaluates to 200. So now we can substitute the 200 in to the equation because we know that that is equal to 2x, because when you take this square of something that was a square root, now you just have the value that was under the radical, so 2x. So now we have a simpler equation, 200 equals 2 times x. So to complete the problem, let's simply divide both sides of the equation by 2 to isolate the variable x. And the value of x is 100. Now that we have solved for x, let's plug it back into the original equation to double check our answer. That is always a good idea on the SAT. The original equation was 2a equals the square root of 2x. So let's plug in 5 root 2 for a and plug in 100 for x. Just like that. All we did was take this second equation that was given in the question and plug in the values of a and x. X is 100, a 5 root 2. So on the left-hand side of the equation, we can simplify by evaluating 2 times 5, which is 10. On the right-hand side of the equation, we can simplify by evaluating the square root of 100, which is 10. So notice how we've used the math rules that we've learned already about radicals and factoring in order to manipulate this equation in the way that we need to simplify to show that they're equal. So now we just have 10 times the square root of 2 equals square root of 2 times 10. And we can already tell this is correct because we know that two numbers multiplied in any order, doesn't matter which order you multiply them, you'll come up with the same product. So this can be rewritten. Simplify by writing 10 root 2 on both sides of the equation. This is correct, so we have confirmed that our answer of x equals 100 is correct. Alright, by remembering these math rules, you can solve these types of problems quickly on your test. Thanks for watching this video. Please like the video if you found my explanation helpful today, and feel free to subscribe to my YouTube channel for more. If you have any questions, feel free to ask in the comment section and I will do my best to reply to everyone. See you next time.